Good morning, students. Today I'll be starting the new chapter, chapter 14, chemical effects of electric current. So what is meant by electricity? Electricity means the movement of electrons. So what is electron? So if you are taking an atom, you know there are three different particles, protons, neutrons and electrons. Though in the center you can see proton. Proton it is positively charged, the neutron it is neutral, and in the surrounding you can see the electrons. Electrons they are negatively charged particle, they are moving through the orbit. Okay, so the movement of the electrons that is known as electricity. So here we are going to learn about the conduction of electricity. Similar to many solids, some liquids also conduct electricity. Okay, solids can conduct electricity. Of if you are taking the common example, you know, in your house, you just think your light or fan is working because from the you will on the switch. From the switch, it's connected to the light through the cables. So inside the cable, what you can see, there is a copper wire. Copper is a conductor. Copper can through the copper, electricity can pass through it because it is a conductor. So similar to many solids, some liquids also conduct electricity. So first we're going to learn what is the difference between conductor and insulator. So what is meant by conductor? Substances which allow electricity to pass through them. They are called conductors, such as silver, gold, acidic solution, salt solution. Most of the metals are known as conductors. So they allow electricity to pass through them. They are known as conductors. Then what are insulators? Insulators means substances which do not allow electric current to pass through them are called insulators. But some substances, they do not allow electricity to pass through them. They are known as insulators. Example, if you are taking plastic, rubber, all these are example, paper, all these are examples for insulators. Clear? Then, what is a circuit tester? So, what is meant by circuit? How can you make a simple circuit? Simple circuit mainly you need four things. One is one cell or battery. Then you need some cable or wire. Then you need a bulb. Here you can connect one switch. The it controls the movement of the electrons or current. Clear. So the circuit which consists of four parts mainly electric cell or battery, commonly we will call battery, then cable and bulb and switch. So what is a circuit tester? Use of a circuit tester to test whether the material is a good electric conductor. So we use this tester. Why we use this? To test whether the material is a good electrical conductor. Okay, so here only we will be going to connect any material, maybe the plastic or wood or metal or anything you can connect here. So you can see that some material it will allow the current to pass through them and the circuit will be complete circuit. Okay, the path will be complete. But in some then bulb will glow. But in some cases you can see if you are keeping one wooden piece or plastic scale or something, you can see that current will not pass through it because they are insulators and bulb will not glow. Clear? How to use a circuit tester? So first you see step one, step up the circuit tester as shown above. So you need battery. It has positive terminal and negative terminal. Then you take one bulb. It also has positive and negative terminals. Then cables or wires you are connecting this way. Then step 2, place the object between the open ends of the wire or crocodile clips. I told any object you can keep between these two wires. Suppose you are keeping one iron nail, you think iron nail, it's a conductor. It can current or electricity can pass through this iron nail because it is a conductor. Then current is passing through it, the circuit will complete and bulb will glow. But instead of this, you can keep some wooden piece or you can keep some plastic scale. You can see that bulb will not glow because they are insulators, it will not allow current to pass through them. Then you also can keep one graphite is actually it's like resistor, like it will allow very limited supply of current, it will allow the current to pass through it but very less. So you can see that light will be very dim light, you can see. Clear? If the bulb lights up, it means the material allows electric current to flow through the closed circuit. So I told you you can keep any material there. So that is the use of this circuit tester. You can keep any conductor or any insulator or anything you can keep. Suppose the bulb lights up, what is the meaning? It means the material allows electric current to flow through the closed circuit. So now circuit is closed. Otherwise, we should call open circuit. Now it is circuit is closed. It's a complete path for the electricity. The brighter the bulb, the better the conductor of electricity is the material. So suppose the bulb it gives more light, so the conductor is good conductor. Okay, it is that is a reason they're telling the brighter the bulb, the better the conductor of electricity is the material. Excuse me. The next one is good conductor and bad conductor. Substances which allow electric current to pass through them easily are called good conductors of electricity, such as silver, gold, aluminium, copper. All these are examples for good conductors of electricity. Some substances allows electric current to pass through them, but in very little amount. Therefore, such substances are called bad conductors of electricity rather than being called as insulator. But some other substance which allow very less current, which allows electricity to pass through them, but in very little amount. Okay. Therefore, such substance what we can call them as bad conductors of electricity rather than being called as insulators. In fact, most of the substances allow electric current to pass through them under certain conditions. So instead of using terms conductors and insulators, we can call good conductors and bad conductors are used. Clear? So instead of conductor and insulator, what we can call good conductors and bad conductors. So good conductors, they allow electric current to pass through them, but bad conductors, they will allow very little amount. Sometimes they will not allow, sometimes very little amount current to pass through them. They are known as bad conductors. Electrical conductors are materials that allow electric current to flow through. Examples, salt water. Metals such as copper, aluminium, and nonmetals like graphite, it's a form of carbon. All these are conductors. So conductors, they are the materials allow electric current to flow through. Example I told salt water. Then metals like copper pipes you can see here, copper wires, aluminium, aluminium you can see fork, spoon, all this aluminium, and non-metals like graphite. See this is a graphite. The pencil lead it is made up of graphite. It's a non-metal. It's a form of carbon. All these are conductors. Copper, silver, aluminum, graphite. All these are forms of conductors. Then electrical insulators are materials that do not allow electric current to pass through. Examples plastics. You can see here plastics. Then wood and rubber and glass. All these are examples for insulators. They do not allow any electric current to pass through them. So they are so that is the reason they are known as insulators. Plastics, wood, rubber, glass, etc. Then how the electric current is flowing through the or passing through the liquid. Let us see. Liquids which contain salt dissolved in them. Okay, salt means the formula is sodium chloride, NaCl, salt or sodium chloride dissolved in them, conduct electricity. Okay, suppose if you are taking some distilled water, you think it's a purified water. Distilled water usually we will be using in the laboratories. It does not contain minerals or it does not contain salt. It will not allow electricity to pass through them. But at the same time, any liquid which contains salt dissolved in them, they conduct electricity. The conduction of electricity through a liquid can be tested using two electrodes and a bulb. How we can test? We can use by using two electrodes and a bulb. You can see here. So this is a cell or battery. This is bulb. These are the two electrodes. Okay. But the conduction of electricity through the liquids which are poor conductor cannot be tested. If the current is very less current is passing through them, sometimes we cannot be tested. But conduction of electricity through such liquids can be tested using LED. You would have heard it, LED bulb. Okay, LED, light emitting diode, or magnetic compass needle. Because in bad conductors or in insulators, usually in bad conductors, very less current can pass through them. But suppose we are using the normal bulb, it will not glow because very less current is passing through it. So instead of the normal bulb, what you can use? You can use LED because LED it needs very less current. Okay, it can glow. And also magnetic compass needle. It will show that fluctuations it will show. Okay, so but conduction of electricity through such liquids can be tested using LED or magnetic compass needle. For this, you need a compass needle, a empty matchbox, two electric cells, some wires, a plastic bottle cap, and a liquid which is to be tested. Keep the compass needle inside a empty tray of matchbox. So what are you supposed to first you should do? Keep the compass needle inside the empty tray of matchbox and wrap a couple of rubber bands around it. Excuse me. Connect the wires to the battery or cell and insert two wires in the liquid. Liquid you have to take in one bottle cap, which is kept in the plastic bottle cap. You will observe that when the current flows through the wire, there is deflection in the compass needle. This shows that the given liquid conducts electricity. Okay, so that needle, it shows a different movement. So what it shows that the given liquid conducts electricity. In fact, magnetic compass needle can detect even feeble current. It's a very less current also passing through it. It can show that deflections or that fluctuations or deflections, the moment it will show. In fact, magnetic compass needle can detect even feeble current. LED can also be used in place of compass needle because LED also need very less current. The bulb can glow. Okay, so here the battery or cell will be here. Here you should connect this compass needle. Then here you think these are the two ends of the wires. You can put inside one bottle cap which contains liquid, but the liquid should contain what? Should contain salt, or it should be you can take some salty solution or salt water, because salt water which contains minerals. Salt means NaCl, sodium chloride. Then s- salts. Salts dissolved in water are responsible for conduction of electricity through water. So, why the current or electricity can pass through water? Because of the salt. Salt dissolved in water, it is responsible for the conduction of electricity through water. Examples: tap water, acid solutions, basic solutions, etc. are good conductors of electricity. But at the same time, I told distilled water is poor conductor of electricity because there is no salt in present in the distilled water. Clear? So tap water, it contains minerals or salt, even acidic solutions, basic solutions. They are all good conductors of electricity because it contains salt or minerals. But in other hand, this distilled water, it is poor conductor of electricity because it does not contain salt or minerals. Test electrical conductivity of liquids. Place the two aluminum plates into the liquid tested. So now what we did before, I told you take some bottle cap or something, you or any one beaker you take some salt water or liquid. What you have to keep now? You have to keep place the two aluminum plates. Okay, this is one aluminum, this is second one. Aluminum plates into the liquid tested. If the bulb lights up, a closed circuit is formed. Suppose the bulb will glow. What is happening? The ions are moving and through this cable and through the cell, and complete is what is circuit is closed circuit or complete circuit. That is the reason bulb will glow. If the bulb lights up, a closed circuit is formed, allowing current to flow through it. The liquid is a conductor of electricity, so that liquid is good conductor of whatever liquid you have taken, maybe the tap water or acid solution or basic solution, it is a conductor of electricity. Okay. Some liquids are good conductor of electricity. Example: tap water, salt solution, hydrochloric acid, sodium hydroxide, etc. Solutions of acids, bases, and salts are good conductors of electricity. So this tap water, salt solution, hydrochloric acid, HCl, sodium hydroxide, NaOH, these all are good conductors of electricity because mainly the solutions of acids, bases, and salt, they are good conductors of electricity. Some liquids are poor conductors of electricity. Example: distilled water, sugar solution, kerosene, spirit. These all are poor conductors of electricity. Okay, so here you can see that in the first figure you can see the bulb will glow because here whatever liquid you have solution you have taken, it is good conductor of electricity. That is the reason bulb will glow. In the second diagram you can see bulb will not glow because whatever you have taken here, the liquid is poor conductor of electricity. But in the third case, here they given one example, they given molten sodium chloride, melted. Sodium chloride means salt. Okay, you can take some salt solution. Take one bulb, battery or cell. You can keep two electrodes. One is anode, one is cathode. The current is passing through it. Okay, so the salt solution or it is acting as a through this current can pass and complete will circuit will it will be complete circuit or closed circuit, and that is the reason light will glow. Okay, thank you, students.